Hello everyone, this is Shreyavati working as an assistant professor in the Department of Artificial Intelligence and Data Science. In our today lecture series, we are going to see about IPv4 which is from the computer networks. Let's we see this topic one by one using design thinking approach. Engaging questions. Before starting, think about this question. How does your laptop or mobile know where to send messages on the internet? Every device needs a unique identity, just like a postal address. First phase of design thinking is empathize. Let's we see about empathize phase of IPv4. Postal address analog in a postal system. We use country, city, street and house number for delivery. Similarly, in network, we use network address, subnet and host addresses for communication. Routers act like postman to forward data packets. Then next one is define phase of design thinking. What problem does IPv4 solve? IPv4 solves the problem of identifying devices uniquely on the internet. It allows communication between billions of devices connected in the worldwide. What is IPv4? IPv4 stands for Internet Protocol version 4. It is a 32-bit addressing protocol that provides unique identification for devices and support packets based on communication. Think pair and share. Now think about this situation. IPv4 supports around 4.3 billion addresses. What problems may occur when the number of connected devices increases rapidly across the worldwide? The next is by overcoming for the previous problem. Next we will see about the ideate session for this problem. In this session we will explore IPv4 concepts, address formats and different addressing methods using in the internet working. IPv4 space and notations. IPv4 addresses contains 32 bits and are written in dotted decimal format like 192.168.1.1, and each octets will be ranges from 0 to 255. The next is classical addressing of IPv4. Initially, IPv4 used class A, B and C networks. Class A supported large organization and class B medium organization and class C is for small organization. This method caused address wastage. The next is classless addressing of CIDR. CIDR or classless inter-domain routing was introduced to reduce address wastages as we discussed in the previous slide. It allocates addresses more efficiently using prefix notations like 192.168.1.0 bar 24. The next is CIDR rules. CIDR blocks must follow three conditions. Addresses should be continuous, block size must be a power of 2 and the first address must be divisible by block size of the address. The next is the prototype of IPv4. Now let us understand how V4 actually works in real network communication using datagrams and routing concepts. Then this is the IPv4 datagram structure. An IPv4 packet contains two parts, as we know, that header and the data. The header stores important informations like source address, destination address and time to leave. Then next is datagram field. Different header field perform different functions such as error checking, fragmentation and packet identification. Then the next one is subnetting of prototyping parts. Subnetting divides one large network into smaller subnetworks. This improves security management and efficient utilization of IP addresses. The next is the IPv4 packet journey. When a packet is sent to uh, the network, routers examine the destination IP address which was present in the IPv4 header format and forward the packet step by step until it reaches the destination system correctly. Then next one is the NAT, that means network address translation hierarchy. It allows multiple devices to share one public IP address. This helps conserve IP addresses. Quick concept of the IPv4. Let us quickly revise the important concepts learned so far, including addressing, subnetting, CIDR, and packet routing. The next is the industry scenario. Large companies like AWS and CIDR blocks and subnetting to manage thousands of servers and virtual machines efficiently in the cloud environments. Next is the IPv4 strength and limitations. Limitations. Then next is the IPv4 is simple, reliable, and universally supported. However, it suffers from limited address and space and lacks of built-in security features. Uh, Next is the discussion activity. Suppose your startup plans to connect thousands of IoT sensors. Would you choose IPv4 with NAT or directly migrate to IPv6? Think about scalability and security. Let's we see the quick summary of today's session. Today we learned about IPv4 addressing, classless and classful addressing, subnetting, datagrams, and how IPv4 will be prototyped using prototype part of design thinking. Next is the next we will see the references. These are the references I have used to prepare this PPT. Thank you for students for listening. Hope this video will give the clear idea about IPv4 addressing. Thank you.